Welcome everyone to the part 2 of this LSTM series, and here we are going to check out how exactly do LSTM works. So, in the in the part 1 of the lecture, we've seen why do we need LSTMs. Now, here we are going to see how exactly LSTM does what it does. Okay, so first of all, there's a philosophy that neural networks try and replicate our human brains. The inspiration for a perceptron, the inspiration for a neuron had actually come from our human brain. So, through our neural networks, through our artificial neural networks, we try and replicate our human minds, because our human mind is evidently a beautiful and a complex piece of machine, and if someday we are able to crack it, then probably we'd witness artificial general intelligence, but I believe that it is way too far for now. But let's check it out. So, talking about human mind, uh, I'd like to ask you one question. Do you remember every single detail that has happened in your life? Like every single detail ever that has happened in your life. Forget life. Imagine you've seen a movie. Do you remember a frame by frame shot of every single thing that has happened in that movie? Or do you remember a gist of that movie? And when I ask you what that movie was like, you will be able to say, okay, look, these were the two characters, this was the story, and this happened to this hero, this happened to that villain, blah 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 blah. And yeah, on the whole, it was a decent watch, it was a good movie, I'd like to watch it again. This is what you would probably say, and this is what how a normal human would respond, unless and until you've seen Bradley Cooper's Limitless and you've taken such pill. But otherwise, in any other case, this is how a normal response would look like. So how does that happen? So what is brain doing? What exactly is brain doing? I mean, what is happening? So a commonsensical reasoning would be that it is deleting all the unimportant information, but at the same time it is retaining information such that I'm able to understand the story, I'm able to remember the important parts in it, I'm able to remember, the scenes that had the most impact on me. Yet, yet I don't have to know the story frame by frame. So it would be safe to say that, a very big story, I'm trying to condense it in a very small part, yet I'm able to retain most of the information. The ethos and the essence of this information I'm able to retain in a much smaller format. Try and do this exercise. You've just watched the movie and come, and suppose there's a friend of yours who's not so keen on watching that movie, but he'd like to know the story of it. Then you are able to tell the entire story of 2.5 hours in 15 minutes to your friend without missing out. Of course, it depends on your storytelling ability, but people are able to do that. They are able to give him what exactly happens in a story, who's the hero, who's the villain, who are the important characters, what exactly happens. So all of this is made possible, and that's the ability that we have in LSTMs. This is our goal. Of all the information that we have, we'll have to discard the unimportant information, but we'll have to retain something that is significantly important, significant enough for us to be able to make decisions out of it, for us to be able to comprehend what is the ethos and essence of that information. So this is how, on a broader scale, if you have a bird's eye view of LSTM, this is what exactly it does. Its goal was to remember, how, if I give it a long sentence, unlike RNNs, it shouldn't become Gajini, but it should remember the complete sentence. And LSTM comes out and says, okay, this is what you want me to do, but I have a limitation. I can only store a certain amount of information. I can't store everything that you give to me, Baba. I can only store a certain amount of information, but I understand your concern. what you're saying is you want to remember the entire context. I have a solution for that. What I'll do is all the unimportant information, all the redundant and kachra information I'll remove, but all the important information I'll store. And whenever you ask me what did I say, with this much information I'll be able to give you a proper answer. I'll be able to predict the next word. This is what LSTM does. Let's see how. Okay, so now that we are clear in what our objective is to condense whatever information that is given to us in a limited space, in a limited size. So basically, we'll have to condense that thing, and that is how our LSTM will work. Now, you know that LSTM is a specialized form of an RNN, or it is a significant improvisation of an RNN. So this is our basic RNN block where we have a hidden state, we have our current input, and this would be as an RNN. This would be our next token or the output, and this would be our next hidden state. So xt, it's our current word. So if I say, let's get back to our example, BMW makes the finest blank. Okay, so LSTM is a language model. A language model has to predict the next word. If it predicts cars or bikes, I'll be able to say, okay, it understands language. Now, a hidden state. Let's say we are here. I've already given my LSTM BMW makes the. Now, XT, I've given it finest, the input to my LSTM, or it's an RNN. You give, so what I'm trying to say is, this is my current word. So my current word here is finest, and in HT minus 1, it's basically a vector which has the information about these words. So BMW makes the, all of this information is condensed in HT minus 1. When I use then, I give it the word finest. After I give this word, it will process, and this token of mine will either be a car or a bike. And BMW makes the finest. This would be my next hidden state. So this was a preview to what an RNN, or what basically a recurrent neural network. This is how basically a recurrent neural network works. So, but our problem was that by the time the word finest comes, this HT minus 1 would lose, by the time the word finest comes, this HT minus 1 would lose the information about BMW. So, the occurrence of BMW, this would not capture. So, we have to overcome this problem. Now, this is our challenge. So, to do this, we basically have 6 characters. 6 characters. So those 6 characters are my forget gate, input gate, output gate, new cell content, cell state, hidden state, and these are the corresponding mathematical equations of it. Now some people might get irritated by looking at all of this because all of this seems a little intimidating. I was also intimidated by looking at all of this. I didn't know what, I was like, what new hell is this karke? But if you try and understand it, it actually begins to make a lot of sense. Now, let's let's look at it. Now, what exactly is forget gate? Now, as I said, let's look at these 6 things as 6 characters. 6 characters in a story that have to do, with each character doing its individual task. Now, what is a cell state? This is something that is very important, where we have to understand what exactly a cell state is. A cell state basically is what we want. Cell state is our objective. It contains the condensed information about all of it that had been spoken. All the input that we gave, the condensed form of that cell state is present in this vector, cell state. That is what cell state represents. So this character will have all of the information in a condensed form. Whatever is unimportant, it will remove. Whatever is important, it will preserve with itself. But if you go and, if you go to this particular character, if you go to this cell state guy, and you say ki, okay, who are you? It will say ki, I am this person who has all the information that has been told to you till now, but in a condensed form. I don't have word to word of what you've told, but enough to tell you what the context was. Now, for this person, for this cell state to achieve that, these start helping: forget gate, input gate, output gate, new cell content, and hidden state. Now, how exactly do they do that? Let's see. Now, first, let's look at forget gate. Now, this is the mathematical definition of a forget gate. So let's come here. In our previous diagram, this is our ht this is xt, this is our xt, this is ht minus 1. Okay, this is my hidden state, this is my xt, this is my hidden state, this is my xt. So these are the weight vectors that this neural network actually learns during training, because this is exactly what it needs to learn during training, these biases and these weights. Once it learns, it will be able to tell. So first of all, what we need to remember is all these six characters are basically vectors of a fixed size. Let's call these n. So all these characters are basically vectors of a fixed size. Now what happens is, you have a sigmoid function here. Now what that does is it clips the values of these vectors between 0 and 1. So the maximum that you can have is a 1 and the minimum that you can have is a 0. So the values of these is that much. These are gates, these are cell states. So now, so what does a forget gate do? What is the job of this guy? What does forget gate exactly? Forget, when we listen to this name, its ability to forget something. So that is what exactly it does. As we said, cell state has some information, it needs to forget. Cell state has some information, it needs to forget unimportant stuff. This guy will give that information. This forget gate will come to cell state and say, okay, this is the information that you have, but you need to forget a few things. Let me tell you what you need to forget. So this forget gate will provide the information of what it will look at cell state, it will analyze all of that information that is present, and it will say, okay Baba, let's forget. There are a few things that you need to forget, start forgetting. Then there is input gate, output gate. I'll tell you about these things, and we've already covered cell state. Let's talk about new cell state. Okay, so this is a new diagram. The previous screenshot was from CS224N, and this is a diagram from Cola. The link that I've shared that I've shared with you in the description. So now let's see. This is my current input that I'm giving. This is my previous hidden state. This is my cell state. This is my cell state. What does cell state mean? At any given point of time, it contains the condensed information of everything that has been given to it till now. Correct? And this is my forget gate. What does forget gate do? Now let's see. It will take my current input and my hidden state. What was our example? BMW makes the finest blank. So let me write it down. So BMW makes the finest blank. BMW makes this piece of information is stored in ht-1. Finest is actually stored in xt. ht-1, BMW makes this information was stored in ht-1 and RNN. But in LSTM, BMW makes the information that these three words carry is actually stored in my cell state. BMW makes the. the information about these three words, the condensed information about these three words, is stored in my cell state. The hidden state, you will come to know by the end of this what does ht minus 1 represents. But in RNN it would represent these things. But since we are talking about LSTM, cell state represents this information. XT is my current word, which is finest. When the word finest goes, it takes this thing. It takes my hidden state. It takes my current word finest, and it will decide, okay, what should be forgotten now. This is my cell state. It already contains this information. BMW makes what is it that should be forgotten, and that would be a vector of size n. Now, as I said, all these 6 characters are vector of the same size. Now let's assume that they are of the size n. What happens exactly is, this will contain some information, 0.5, 0.6, it's a random vector. My cell state will contain some information, and my forget gate is also a vector of the same size, but it will contain values between 0 and 1. It might be 0.1, in some cases it is 0, in some cases it is 0.3 or 1, or it's between 0 and 1. What I'm doing is I'm multiplying these two things. I'm multiplying 0.5 by 0.1. I'm multiplying this vector by 0. This might be 3 or 6 or something, and I'm multiplying. So in a sense, if you try to look at it from a non-mathematical point of view, mathematical point of view, my cell state is containing information in the form of a vector about these 3 words, and by using forget gate I'm multiplying. When I'm using 1, I'm saying, okay, this piece of information is important, keep this thing. Here when I'm trying to multiply this with the word say 0, I'm saying, okay, this is unimportant, remove this, delete this. This is not important. I can do without this information. It's totally fine. Just delete it. That is exactly what I'm doing with my forget gate. So this forget gate would be a vector of size n, which will help in my current state to lose all the redundant and unimportant information based on what my current word is. That exactly is my forget gate. Now let's talk about my new cell state. My new cell state will take my hidden information, my hidden state, my current word, and it will calculate. If you can go back and look at the equation, the new cell state, there's an equation of, it's a tan H equation about, using these two things, using its respective weights and bias. What does this information mean? So by the time my information comes here, whatever the value is present here, this again is a vector. It's an n-dimensional vector. This represents the new piece of information that has come. I added the word finest. This new piece of information based on the hidden state and my new state, this will come and say, so this vector will tell, okay, this is the new piece of information that you don't have. This is the newest word that I have spoken. Use this information, add this to your this thing. So this would be, okay, this is something that has newly been added. Now add it to the previous words that I've spoken. So join this word karke aata. Now what my input gate does, what my input gate will do is, it's like a gatekeeper. So these are gates, right? So what is the work of a gate? It either allows a few people, it does not allow a few things. So it's basically like a gatekeeper. So what does gate do? It either, if you have access, it will allow you. If you don't have access, it will stop you. So now my input gate will come. It will come and say, okay, you've given all of this information. That's wonderful, beautiful, brilliant. But I can't allow every single piece of information that you give. Look, see, we have a problem कि हम लोग we can't store information, all of the information that you've given. We don't have that much space, Baba. So what I'll do is, whatever is important to me, because your word is important to me, you've given this word finest. Brilliant. Whatever is important to me, I'll take. Whatever I can do without, I'll stop you. That is what my input gate will do. It will take the information from this new cell state, all the new information that has come. This gatekeeper will assess this thing, and again, see, it's a multiplication. So that again is a vector which is clipped between 0 and 1, and you start multiplying these two values. So whenever it is 0, okay, unimportant piece of information, delete it. Whatever is important, it will take it. And this vector, after this multiplication, whatever you get here, it's again a condensed piece of new information. So whatever new information has been added, you've condensed it, and you've deleted. Condensed in the sense you've deleted whatever is unimportant and you've added it. So by the time your current cell state, by the time you are in ct is again the vector. This is what we wanted. So BMW makes the finest. Now this ct has captured this information. BMW makes the finest in the same size, but without losing without losing the meaning of this BMW makes the finest, and removing all the unnecessary information. In an n-dimensional vector, it has managed to do that. Now again, so we've achieved our objective. Our objective was to condense this piece of information. So the beauty of it is BMW makes the these three words were previously represented by an n-dimensional vector. After the word finest had come, BMW makes the finest. These four words are now stored in an n-dimensional vector. So to add this piece of information, finest, so if you can understand, just hit the pause button and just have a look at it. Previously in an n-dimensional vector, three words were represented. Now in the same n-dimensional vector, four words are being represented. It could only be possible if something from this gets deleted and in place of that, new information is added. That is done by forget gate and input gate. Now this CT will contain the information BMW makes the finest. Now let's talk about output gate. As you can see, this is again a sigmoid function, and what my output gate does is it will go to my cell state, and okay, now since what is this? This is basically a language model. So the primary objective of my language model is to predict the next word. So my objective is BMW makes the finest what? Is it a cat, dog, car, bike, bus, aeroplane? It has to predict something, right? So in an RNN, if you recall, if I had my previous ht minus 1 and my current xt, I would get, this would be my current hidden state and this would be my output. This would be my token. So if this were to be an RNN, if xt was finest, the output, this token would be my car or a bike. Now in my LSTM, that work is taken over by my hidden state. So my hidden state, this ht vector, it's again an n-dimensional vector. All vectors are of same size n. It's an n-dimensional vector which will represent, say, a car. Let's assume it's a car. So this ht will represent the car. And my cell state will contain all the condensed information. So ht, this vector will represent car. Ct, this vector will represent BMW makes the finest. Now, to get this ht vector, this is my output gate. My output gate will go to my cell state and say, okay, you've got all the information, but to say car, I don't need all of that information. Just give me information enough that with which I can get my ht. So again, it's it will take this cell state, it will take the current cell state, and it will multiply it will multiply my output gate. Same thing, there are two vectors, you're multiplying them. What is important, you're keeping. What is unimportant, you're removing. And with this, you will start getting your vector HT, which represents a car, and cell state represents the complete information. HT represents your token. So this is what you can use. Hope I've been of some help to you. This was me trying to simplify LSTMs. So in case you like it, please do like, share, and subscribe. And thank you so much for your patience and listening to it. Bye. Take care.